All right, welcome to DellyMaths Concepts. What we're actually looking at is our EOC geometry exam tips. All right, so if you're new to the channel, like the video, subscribe to the channel, and share to your friends. All right, let's go. Question one says, Kelvin is at house. Kelvin is, hold on, let's put on this. All right, so Kelvin is at his house at 3, 4, and that's a coordinate. This is x, this is y, this is x, this is y. So we're talking about it's at 3, 4. All right, good. On a coordinate plane. And he walked to a store. Do this over. All right, question one. Kelvin is at his house located at 3, 4. So x is 3, y is 4 on a coordinate plane, and walks to a store located at 1, 0. The store is located exactly halfway between Kelvin's house and Mitch's house. All right, no problem. To the nearest tenth. All right, what is the distance? All right, between Kelvin and Mitch. Basically, this is dealing with the distance formula. So basically, it is suggesting that the distance. So let us call the distance. Let's call the distance. I'm going to say d. So the distance d is equal to the square root of our x2 coordinate minus x1, and you're going to square it plus the square y2 minus y1, the difference square. Boom. All right. And then after that, we're going to W, but we're going to talk about that. So let us call this x1, x2. Let's call this, let me fix these up for us, my bad. Let us call this x1, y1, x2, y2. So let us plug them in. All right, so basically what we're doing is that x2 is 1, so it's going to be 1 minus 3. We're going to square that, plus y2 is a 0 minus 4, and we're going to square that. Let's go. This is actually negative 2 squared plus negative 4 squared. And we're looking at 4 plus 16 squared. So this is the square root of 20. The square root of 20, though, is going to give us about 4. This is about 4.4. Right, 4.47. And remember now, we were told that this distance between the house and the store is halfway between Kevin to Mitch. So we want to double 4.47. Let's multiply this by 2. And then we would have gotten 8.9, and this is the answer. So we're utilizing our distance formula as we go along there. Now, question 2. A circular sidewalk is being constructed around the perimeter of a local park. A brick path will be added, through the diameter of the circle as shown in the coordinate plane here. All right, let's get to the chase. It says, what is the x coordinate where the tree is planted? Remember that the tree is planted at the center. You're told here that the tree is planted at the center. So we're looking at the center. But if I have two x coordinates, for example, look at my coordinates. We have x, y, and we have 9. So this is the diameter that we're dealing with. So the diameter does pass through the center. So I could take my x1, x2. All right. If I'm going to find the center of the circle, all I have to do is to add my x values, divide by 2. Right. So this is going to give me 8 divided by 2. This is going to give me 4. So this right here is going to lead me to the center right there, 4. So my x value is 4 at the center. And that's what they wanted. Question 3. If the figure below, in the figure below, lines K, M, and N are parallel. So let's highlight the parallel lines. 1, 2, 3. So we have 3 parallel lines there. And let's continue. Question says, what is the sum of the measure of angle 1 and angle 2? Let me highlight what we're finding. This is angle 1. This is angle 2. Let's find them. All right. So I'm going to zoom in on these 2 yellow lines that I put here. So M and K. So if I zoom in on M and K, they are parallel lines. Angle 1 is alternate to angle 50. So that means this is 50 degrees right there. Also, if I utilize my interior same side, so 150 and the measure of angle 2, right, will give us 180. So the measure of angle 2 is going to equal to 180 minus 150, and that's going to give us 30. This is 30 degrees. So then we're looking at the fact that if we should be adding 50 at 1 plus 30 at 2, our answer is going to be 80 degrees. So that's the answer for that, 80 degrees, which is A. Let's go to number 4. What regular polygon has the exterior angle that measures 60 degrees? All right, the thing about exterior angles, for all polygons, exterior angles would add to give 360 degrees. So it doesn't matter what side, how many sides it has, the measure of the total exterior angle will be 360. Now, when we use the term regular polygon, it is saying that all the external angles are the same size. So if I should divide by one of them, so if I should divide 360 by 60, it's going to give me 6, right? So what is that telling me? It's telling me the number of sides that we have. So it is a 6-sided figure, which is called a hexagon. The answer is B for number 4. All right, let's keep going. For number 5, it says, which of the equation of the circle shown below? Which is the equation of the circle that is shown below? All right, so you want to observe this. Take a good look at it. You want to deal with this, you're taking a good look at it. If I should blow this up some more so we could see it better, you want to take a good look at your circle. So as you could see, the center is right here. What is the coordinate here? This coordinate is -3 meets 0. And then in terms of unit from the center to the circumference, it's 1, 2, 3. So this distance is 3 units. All right, so I could now utilize that to help me. I have the radius and the center, so I'm going to put it in standard form, or what we call the radius center form. Now take a look at the equation of the circle in that form. It says x minus h squared plus y, this is my y, minus k squared. And this is equal to radius squared. So basically what I'm going to do is I'm going to use my center, right? So this is what we're going to do. So x is here, minus is already there. This is -3 right there. And we're going to square that, plus y minus 0, square that, and it's going to equal to 3 squared. I'm looking for this, right? So these two negatives will become positive. So I'm looking at x plus square plus y square, and then this is equal to 9. I'm looking for that. So it is definitely at D. So basically, understanding the principles, we put them into action and then we go. Let's look at question 6. Question 6 says here, a solid glass sphere is cast with a radius of 30 centimeters. What is the volume to the nearest whole number of this sphere? Well, let's take a quick look. The volume can be found by using this formula for the sphere, 4/3 pi r to the third. So all we're going to do is to work this out. 4/3 times pi, I'm going to use 3.14 times r to the third, which is 30 to the third. All I have to do is to put this on my calculator. So let's go. All right, so when I do that, I'm getting 113,040, and it is right here. All right, so the answer is C for number 6. All right, let's keep going. Number 7. Number 7 says you are trying to prove that quadrilateral EF is a square. You have already proven that all 4 sides are equal, they're congruent. So we have already proven that this side is equal to that side and this side is equal to that. They're all congruent. All right, no problem. Which statement all right, if true, would prove. Now remember, now we're going to have to put into action one other property of a square that we know. Now, the property that we're going to focus on is that the diagonals of a square are congruent as well. The diagonals are congruent. So we're focusing on the diagonal. We're looking for anything that speaks to that. The diagonals are congruent. I'm going to take this and go. And the moment I see that one thing that I'm looking for, I am not going to check anything else because there is only one correct answer, right? So the diagonals are actually the same. Now let's take a look at question 8. Question 8 says, polygon STUVW is shown. We're looking at it. After polygon STUVW is reflected across the y-axis, all right? What are the coordinates of S prime? All right, so whenever we reflect in the y-axis, this is what happens. So let us look at the coordinate S. It's -5, -2. This is X, this is Y. When we reflect, right, in the y-axis, what's going to happen is that the y coordinate will remain. So definitely this will be -2 still, but the x coordinate would have to change its sign. So we're looking for a +5, -2. It's going to be over here. It's going to be right here. So that answer is actually C. So when we reflect in the y-axis, the y value remains, the x one changes. Number 9. A rope is tied to the bottom of a hot balloon, as you could see. The rope makes an angle of 35 degrees right here. Okay. All right, we're seeing that diagram. How far is the bottom of the balloon from the ground? So we want to find this distance. All right, because it's a right angle triangle, right? We want to find the opposite side to 35, and we have the hypotenuse. So we want to think of this. Let's write so ka tower. All right, so we're dealing with so ka tower. So we're dealing with opposite and the hypotenuse. So we could say the sine of 35 is going to equal to, let me call this side x, x over 75, which means that if we should multiply both sides by 75 to get the x alone, 75 times the sine of 35 will take us to the answer. And we're looking for 43. Here it is. That's the answer. All right, so number 10. The captain of a submarine views an iceberg from a periscope, as shown in the figure. What is the height of the iceberg to the nearest meter? So again, we're looking at angle of elevation, as you could see. So this is opposite, and we have the adjacent side. So again, so ka tower, right? We're going to be using tan, opposite, which is this side, and the adjacent leg right here. So let us deal with it. The tangent of the angle, which is 40 degrees, is going to equal to opposite side. I'm going to call this x over 250, which means if I multiply both sides by 250, then it's going to tell us the height of that iceberg. So 250 times tangent of 40 degrees, it's going to take us to about 209.7, which is about 210 to the nearest meter. C is our answer right there. Below is a drawing of Jeff's yard. There is a circular fish pond near one corner. The diameter of the pond is 12. How many square feet of grass are necessary to cover everything except the pond in his yard? So what's the pond? So the pond, okay. All right, let's look. It says the pond, the circular pond near one corner. Okay, the diameter of the pond is this. All right, so, okay, so you could work out the area. Okay, so what you're gonna do is to just work out the area and subtract the area of the pond, right? So how many square feet of grass are needed to cover everything except the pond. All right, let us work out that for this shape. This is a trapezoid. So we can find the area of this easily, of the trapezoid, by doing this. It's going to be 70 plus 100. All right, half of that. And we're multiplying this by the height, which is 60. All right, so let's work this out. All right, so this is going to give me, this is 170 right here. So all I have to do is just to put this together. So 60 times 170, divide that by 2. And it's going to give us about 5,100 here. But remember, though, that we're going to have to take this out of it. So the diameter is 6, which means that R, which is the radius, the diameter is 12, so R is 6. So remember, the area of a circle is pi r squared. So let us say I use pi as 3.14 times 6 times 6. So we're going to take that from the total. So that's about 113.4. So the answer should be somewhere around this. We're going to subtract this from it. All right, 4987. So I'm getting this for the answer here. 4987. All right. So number 11 is B. All right. Let's keep going. Number 12. What is the converse of this statement? Remember, the condition, let us say we have our condition. So our conditional statement will be P. If P, then Q. Converse is the reverse of this. So the converse is going to be if Q, then P. So that's all the converse is. All right. So if we have our condition, if P, then Q, the reverse of it, which to switch places. For example, if a road sign is red, then, right, it is a stop sign. So we're going to have if a road sign is a stop sign, then it is red. This is reversing the order. So 12 is going to give us A. As you could see, when we're dealing with the converse, we have our conditional statement, and then we're just going to reverse the things, all right? Put the then where the if is and the if where the then is, and we're good. The diameter of a tractor is 5, so feet. We have this. Round to the nearest hundredth. This is actually 2 decimal places. How far will the tractor move when it rotates once? So if you rotate once, all we're looking at is actually the diameter, the circumference. So to rotate once is circumference you're looking at. Once, circumference. So the circumference C can be found by using pi times diameter, or you could say 2 pi r. So since I have diameter here, I'm going to use this. So pi, I'm going to say 3.14 times diameter, which is 5. So I'm looking at about 15.7 exactly, and this is the answer at B. So 13 is B. So the idea is to understand that if you mark a spot here and the tractor moves the distance as it moves along, when you complete one rotation, when this part hit the ground again, we are saying that the distance it would have moved would have been 15.70, right? So that's one rotation fully. All right, let's go to number 14. Number 14 says, an engineer designed a steel beam shown below. The horizontal part that form the top and bottom are parallel. Okay, so they're suggesting that this is parallel to that. Okay, we're noting that, taking note of those. All right, to build across the process, the engineer needs to use the measure of the angles. All right, so angle 1 measure is 110. They're telling us that this is 110. Angle 2, we're told this is 105. Let's see what the question wants. The question says here, what are the measures of angle 4, 3 and 4, right? Okay, 3 and 4. Take a look. Angle 3. Let me highlight these. We have two transversals here. Here is transversal 1. No, not transversal. Parallel line 1, parallel line 2. So I'm going to create the transversal now. So the transversal, cut those lines. So if I cut this with the blue, that's a transversal. So this angle here is going to equal to this angle here. Alternate angles are equal. We call them Z angles. So already angle 3 must be 105. So this is wrong. This is wrong. This is wrong. Oh, this is the only answer then. Because what happened is, when I see one unique idea that I need already, I'm not even going to check the next one. So the fact that angle 3 should be 105 and I'm only seeing one angle 3 at 105, B is the answer, and I'm going to the next question. Number 15. What is the measure of angle E? All right, in the parallelogram. Now, remember that when you have inside, right, when you have angles on the same side, they're between the parallel lines, they are always going to be supplementary. So, or you could say, whenever you have a parallelogram, consecutive angles are supplementary as well. So guess what? If I take 180 and I take out 35, it's going to give me that angle. It should be 145, but I'm just going to make sure. So yes, 145 is going to be that angle at E. All right, that's 15. Now let's go to question 16. A meter stick is held perpendicular to the ground, right? So if this is the ground, the meter stick is held perpendicular to the ground like this. Say it meets it at right angle. It forms a shadow. It forms a shadow that is 1 point. So there is some shadow. So there's a shadow that is falling somewhere here. So we're told that this shadow is 1.8 meters long. All right. At the same time, a flagpole forms a shadow of 7.2 long. Okay. How tall is the flagpole? So let us just quickly look at our flagpole here. So this is our flagpole, and it did form a 7.2 meters here. Now, the sun is somewhere here, right? So the sun is somewhere here. So what's going to happen is this angle here is going to be the same as this angle here. So that's why they said at the same time. So we're saying that the sun is at the same place. So the angle formed will be the same. The angle coming in from the sun will be the same. So think about it. If this angle here is this angle here, also this angle here will be this angle here. They are 90 degrees. That means these triangles are what we call similar triangles. So what it means then, I could take the corresponding sides and I could form a relationship. For example, I could say, there are many things I could do. I could say if I divide 7.2 by 1.8, it's going to give me 4. All right. So that means here, this is like our scale factor. If I multiply this, in other words, then 7.2 is 4 times this. So if I take 1 and said 1 times 4, it's going to tell me the length of this side, because this side corresponds with the meter rule. So we're looking for 4 as our answer. All right, because we're utilizing that. There are many ways you could have worked it, though. There are other ways you could have worked it. You could have found the angle, and then when you use it back, you're going to get that same answer. So because the triangles are similar, because the rays of the sun are coming in at the same time, so it's creating the same in terms of proportional idea with the shadows. All right, so we want to make sure that we see how they're using similar triangles and so in our question. So the answer is 4 for number 16. So that is going to be B. All right, figure ABC below is a quadrilateral. What is the value of X? All right, in order to find the value of X, you need to know what's the total interior angle of this. So ordinarily, if you remember, because this is a 4-sided figure, four-sided figure would have a total of 360 degrees on the inside. That means this angle plus this angle plus this angle plus this angle would give a total of 360, and we can use that to solve the problem, right? So let us, if you don't know that, what you can do though is to try to know the total interior angle, which you could stand at any one point. So let us say I stand at D, and I'm going to create as many triangles as I can without overlapping the lines from any vertex. I only can get 2 triangles from this, which means that the total interior for this one is 180, and another one over here is another 180. If I add these together, that's how I'm going to get 360 for the total interior angle, right? So if not working out this, you want to make sure that you can memorize that it's 360. What this means, if I'm going to find the value of x, I could put together these ideas: x plus 15 plus 2x minus 5 plus 3x plus 80. All of this is 360. Let's put together our like terms. Like terms are as follows. I'm highlighting them for us. So putting together the x term first. X plus 2x, that's 3x plus another 3x, that's 6x. Let's put together the numbers, the constants. 15 minus 5, that's 10, plus 80. So that's 90 right there. So this is plus 90, and this is going to equal to 360. Let's take away 90 from both sides. We're solving for x now. So 6x is going to equal to about 270. Let us divide this by 6, right? So 270 divided into 6, we're going to get about 45 degrees. And so C is the answer for number 17. Number 17 is C. Number 18, which theorem can be used to show that the triangles below are congruent? All right. Now, as you could see, you want to make sure that you remember these ideas, right? So look what we have. They say congruent. So we have 9, and then we have an angle, and then we have the angle, then we have 7, and then we have 7. So what you're noticing here, we're seeing a side matches with that side, then an angle matches with this angle, and then a side again match with that side, right? So what are we dealing with? We're dealing with side angle side, right? So this is a side angle side. So my answer would be at C for number 18. So it's just to look on the ideas, all right? So side angle side works for congruence. The surface area of the sphere below is 4 pi square, right? Okay, 4 pi squared, that's the surface area, no problem. If the radius were to be divided by 2, how would the surface area be affected? All right, let us put together this idea. All right, so what this is saying is, based on our understanding, right? If we're going to find surface area, I want us to look on the formula. The original formula is going to be that, okay, if we have r, which is a part of the whole thing, 4 pi r squared, and we're focusing on r. So if my r was divided by 2, all right, let's think about the r. So if the r is divided by 2, remember in r squared, whatever this is, it was squared. So I'm looking at the concept here, r squared. So if my new r is going to be the original r divided by 2, look at what I'm going to have. I'm going to have r squared over 4. I'm still going to have r squared, but no, it's not just going to be r squared. It's going to be r squared divided by 4, which means this thing will be 4 times as small as it was. So the surface area would be 4 times smaller. I like the answer at C. So it's just to put together thoughts and principles that you know, write on them and you will be fine. Number 20. Jeff lives on Oak Street and Tom lives, so Jeff lives on Oak Street and Tom lives on Main Street. All right, where's Oak Street? Oh, okay, we're seeing Oak Street. We're seeing them. All right, I could highlight them. Oak, Main. All right, so we have those. All right, let's see what they really want. Question. So the question says, how much further to the nearest yard it is for Tom to walk down Main Street and turn on Oak Street to get to Jeff's house than if he traveled the shortest distance between houses through the empty field. All right, so what we want to do with this problem is that we're going to focus on the distance. They're asking us to find this distance, right? You want to find this distance, and you're going to compare that distance with walking along this road and that road. So let us add these first to see what we'd get. So if you should add the 110 plus the 62, he would have walked 172 yards from here to get to here along this road, right? Now, if we're going to focus on the other idea, what we're going to do now is to use Pythagorean theorem. So we are finding the long side here. Let us say I call this x. So x squared is going to equal to 110 squared plus 62 squared. 110 squared, 121, 0 plus 62 squared. That's about 3844. Let's add those, plus 121, 0. And we're looking at x squared is equal to 15,944. So I'm trying to find that length there. So we take the square root, right? So when we take the square root of this, it's going to give me like 126.3, basically. So now if we should subtract, so let's take 126.3, it's going to give us the extra you would have walked if you had taken that road. So basically, that's what the question is about. I'm getting 45.7, which is roughly 46. So when you subtract, I'm getting 45.7 and round it off, that is 46. So right here. So what that is simply saying is so if he had walked Main Street and then go here, he's going to walk 46 yards more than if he had just cut through the field and go there. That's what we're looking at. Let's look at 21. So at 21, it says here, at 21, where are we? 21. 21 says cylinder A and B have the same height. Okay. The radius of cylinder A is twice the radius of cylinder B. All right, no problem. What does the volume of cylinder A compared to the volume of cylinder B, all right, is like? All right. So let's take a look at this idea. All right, so let us just put, all right, so let us say we look at the radius of this one. The radius of this one would be a x. Let's say I call that x. And remember that the radius of the bigger one, though, of this one is actually 2 times it, so it's 2x. In the formula for, if we're going to find the volume, we would have to work with the square of the radius. So take a look. I'm going to square x, you get x squared. If I square this, though, I'm going to get 4x squared. You're noticing that I'm still getting back x squared. It's just that this one will be 4 times whatever this is. So what I'm looking at is A will be 4 times. All right, so cylinder A has 4 times exactly. This is what I want. Because so with these questions, it's just to put together the narrative and to put the things in the right order and then execute what you know. Why would I square it? It's because the area of the circle must be squared in order to find the radius of the circle must be squared in order to find the area. So I have to square the radius. So I square them both and then look at the difference, because remember, they have the same height. So that part would have not been necessary right now. Let's go at 22. 22 says, the perimeter of the square below is 36. What is the length of the diameter x? Of the diagonal x? Now, remember though, let us quickly, it is a square. So if the perimeter is 36, if we should divide this into 4, we're going to get 9. That means every side is 9, basically. Now, again, the second thing that we want to focus on is this is a 90 degrees, which means it's going to take me to my special triangle right there. It is a special triangle where this is 45 and this is 45. All right, because it's an isosceles right triangle, so it's special. Now, here's the thing. If I want to find this, remember though that in those triangles, the hypotenuse side is root 2 times the short side. So it's root 2, or you could say 9 root 2, or root 2 times 9. That is all we're looking for. And that is the answer. No working out. And if you want to work it out, that's fine. But again, if we remember the principle, right? Because remember, the principle that it is based on is this. So if this is 45 and this is 45, if this is x and this is x, this is going to be x root 2. That's the principle on which this is based. So whatever number, this is 9, then it's going to be 9 root 2 without working. So it's just working with principles. All right, so that's 22. 22 is D. Let's go to 23. 23 says the triangle JLK is translated 4 units to the left. So we're going 4 that way, and then 5 up. Then we're going to go 5 up, right? All right, so what are the coordinates of the image of J? Now you can do that many ways. You could take if you understand what that means, to the left and so on. Remember though, to the left is to subtract and up means to add. So if we're using algebra, let's take a look at the point J. The point J is -2, +1. This is the point J. If I'm going to use algebra on it, remember, if I'm going to the left 4, it means to take 4 from that. So I'm going to end up with a -6 already. And if I'm going to go up 5, it means to add 5 to that. So I'm looking for a -6 already. And my answer is C. Now, let us say you don't remember your algebra that well. Fine. No, you're going to move this to the left. Let's take a look. You would have moved it 1, 2, 3, 4. 4 is going to be -6 here because this is -5. So -6 will be right here. And then you're going to go up 5. 1, 2, 3, 4. That's at 5 already. You need 1 more. 5 would be at 6 here. So you could see our -6, +6. It's off the grid, but in context of what you know you have to do. If you're walking it using your direction on the grid itself graphically, then you have to take into consideration what you're dealing with. But in any case, -6, +6 is the answer we would have gotten anyway. Let's go to 24. 24 says 2 parallel lines M and N are cut by a transversal T as shown in the figure below. So we're looking at that. So angle 2 was given. Angle 2 was given as 2x plus 7. Angle 7 is giving, where's that? Right here. It's giving as 3x minus 13. What is the value of angle 7? All right, good. So remember now, if we know the relationship between this angle here and this angle here, we're good. These two angles are what we call exterior alternate angles. So they are alternate, but they are outside the parallel lines. They are congruent, which means that I could equate the ideas. 2x plus 7 is equal to 3x minus 13. They're congruent, so I'm going to equate them. Now I'm going to solve. So whichever way you want to solve. Let us say I want the x's on my left side. So I'm going to subtract 3x from both sides. So I have negative x plus 7, which is equal to negative 13. This and this would have been gone. I'm going to subtract 7 from both sides again, so that the negative x is alone, negative 20. And then as you could see, I'm going to multiply everything by negative 1. So x is equal to 20. That's not the answer to the question, right? X is 20. They want us to find the measure of angle 7. So this is 3x minus 13. You do remember that x is 20. So we're substituting 20. So we get 60 minus 13, and this is about 47. Here it is. All right, let's continue rolling at 25. So 25 says, the following information is known about the quadrilateral ABC. So even if I just draw a quick quadrilateral and I make it up, right? So I'm going to label from A to B, C, and D. And when you're labeling, you have to go in one direction with your vertices, right? So naming those vertices do not switch up. So if you're going ABC like this, you could go that way, or you could have gone this way. But it doesn't matter. Whichever way you go, be consistent. Keep it. All right. So let us label some ideas. We're told that BC is parallel to AD. All right, no problem. BC, DC. This is parallel to that. All right, no problem. So these are parallel, no problem. Then we have other information now that says AB is not congruent, not. So we're told that this length is not this length. Well, that is serious. All right. So what it does, it tells me then something is going on. So let us take a look at what we do have. Right. Now, which must be true of the quadrilateral ABC? It can't be a rhombus because for a rhombus, all the sides are congruent. So I'm using this as my vehicle to propel myself. Rectangle, opposite sides must be congruent. Parallelograms are all these. So this is out. So definitely the only answer there is a trapezoid. All right. We have one pair of parallel sides and the others are different. So even though your diagram may not look right, the diagram would have really looked like this. This is parallel to this. All right. All right. So you have two parallel sides and then the other sides are not congruent. So the diagram would have looked something like that. Like basically this is A, B, C, D. When you fit up all of those, it's a trapezoid. All right, let's go to question 26. 26 says, how much paper is needed to cover a rectangular bulletin board that is 29 and 37? Okay, basically they're asking you to multiply these because the area of a triangle of a rectangle is the length times its width. So it's 29 times 37 and we'll get D. A scale drawing of the side of a house is shown below. What is the best estimate of the area of the side of the house? All right, so this is a side. In other words, then, let me quickly show you what we're referring to. We're referring to a house. All right, that looks like this. And basically, that's a sketch of it. Right, so we're saying that, hey, we saw, all right, so that's it. So this is a side and that other side is around there. So we're talking about this side of the house. That's a side. So we're told that this is 36 square feet each one. So all I'm going to do, there are many ways to do this, but one of the quickest ways to do this is just to count up how many of these I could get. And then, as you could say, they did say best estimate. You're not going to get the exact thing, but you're going to use the closest answer to yours. All right. So I'm going to count all the squares that are fully covered within the shape. And then I'm going to add the pieces to create more squares. For example, I'm seeing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I have 24 solid squares that is fully covered. Then I'm going to piece in the others to create more. All right. So basically, I could say this and this becomes 25. This and this becomes 26. And I could say this and the other little piece is 27. So technically, I'm saying I'm working with 27 of those. Each of them is 36 square feet. So it's like 27 times 36. It's going to take me to 972. This is not there. But which one of these answers will be closest to this? The closest one to this is 1,000. So I would pick 1,000. All right. Even if somebody count and they get, let us say 28, you're looking at 28 times 36, you're going to get 1,008. If you had counted and you get 26, 26 would have been 936. It is still closest to this. So long and short, we're saying that we're using estimate, good estimate, based on the knowledge that we have. Let's take a look at 28. 28 says the arrow above represents the needle of a compass. The needle is rotated 180 degrees, all right? Clockwise direction. What are the coordinates of the, all right. When we actually rotate, when we rotate 180 degrees, this is what really happens. So I'm just going to give a quick disclaimer. When you rotate 180 degree in any direction, all that happens is that the signs of the coordinate change. That's all. So if we have a positive 8, positive 6, we're expecting it to be negative. Let me go back. I think I said the wrong thing. If I had a positive 6, positive 8, it's going to be negative 6, negative 8. So in other words, then the sign will change. And if it were negative, it becomes positive, positive becomes negative. So I had two positive numbers here. So I'm going to get negative 6, negative 8. I'm looking for that. And the answer is C. We don't got to do anything big. All right. We don't have to do anything. Trust me. All right. Let's go. 29. 29 says, Francis bought a new refrigerator to replace the old one, as shown. Our new refrigerator has the same length and width as the old, but is 8 inches higher. Okay, so it's 8 inches higher. So I guess this is the old one, right? How many more cubic inches of space are required in Francis' new refrigerator compared to the old one? So we're looking at the fact that the other one is a little bit taller. All right, so let us look. I could basically take this here and go up with it. So what's the question? How much more cubic inches? How much more? How much taller? 8 inches taller. So basically, all you got to do is to take this area and bring it up by 8. So I'm going to take this and then I'm going to bring it up 8. That's all. Bring it up 8 in the here to create that extra. That. So we have 30, 36 by 8 to get that extra space. All right, so we're multiplying all of these. I'm getting 8,640. A. All right. We're at number 30, winding down. So it says here a cereal box is 10. The cereal box is 10.1 inches high, 7.1 inches long, and 2.3 wide. What is the volume of the cereal box running to the nearest? All right, so all we got to do is to multiply these measurements. We got to multiply these. Length times width times height. Multiply these. 10.4 times 7.4 times 2.3. 177. Right? So what we're looking at though, what we're looking at here is inches. 177. Right there. All right. All right. So we're going to pause there. This is part 1. Look out for part 2.